Alright, so what I have done since the last clip, I know this is probably not going to see it because I'm zoomed out, but I've got 1, 2, 3, 4, 5 capacitors down here in this corner replaced. I also replaced the voltage regulator that's here. Sorry, you can't see. I've replaced these capacitors down in this corner, and then we've got a voltage regulator mounted on the chassis, and then we've got another voltage regulator over here just floating free. I've replaced those, and that's all I've done so far. Oh, I take it back. I've replaced the capacitor over here as well. Still need to replace the rest of them in this section. I got a couple that is bulbous. I got 2 electrolytics in this section I need to replace. I still have the one on the face to replace, and then I need to replace these right here. Now these ones are kind of bulbous. I also got a couple in the front that's bulbous as well that will need to replace. The couple over here, they were bad, bone dry, nothing more to give. However, with that said, we have made a little progress, and let me get this set back up so you can see. And we're going to do this first off of 12 volt. So we're going to connect negative to the chassis, and then we're going to hook positive to the input. You can barely see it in your screen. Let's swing you over a little. Alright, so we can see everything, although it's afar. You can see that we still have 16 volts coming out, and the amps will show us what it is here when we turn this on. So let's go ahead and do just that. We'll plug this back in, put this on amps. You can see automatically the device turned off. Just giving it power, I get a 1/2 amp draw. We'll turn this on, and as you see, that does climb a little bit. We're at 0.89, so 0.9 amps. However, we do have a readable display. If we were to go below 16 volts, our display is no longer legible. Right now, it's in manual. Well, it's not manual mode. We've got the squelch adjusted, and as you see, it scans. So that is really exciting. We're going to come back to that in just a moment. We'll go ahead and remove our power supply voltage. And in our last clip, when we applied 120 volts, we did not have a legible screen. It was illuminated, but not legible. So I'll go ahead and plug this in. 120 volts. We are plugged into the isolation variac. Let's go ahead and hit that, and we'll turn this on. And not a legible screen, which is kind of odd because when after I put in the voltage regulators, I had a legible screen. So interesting. The one thing to note is, well, I don't know if you want to note it or what, but the voltage regulator was getting hot. It's not anymore. However, I do have a 3-watt wire wound resistor underneath the transformer that does get pretty doggone hot, but not immediately. It does warm up to it. So what I'm thinking now, the reason why that gets hot, the transformer of course gets hot, and this whole section gets hot. I think what's happening is I may have dry capacitors in the power supply area. I do have one of them that is bulbous, and so I'm going to pull those out. So that was working just fine after I replaced the voltage regulator. Again, it's very plausible that because the capacitors are dry, if that's what the issue is, that's what the issue is. And I'm going to replace those, and hopefully we won't have that. So let's go ahead and fire this back up. Fire this back up on 12 volts. That way I could show you a few other tidbits. Alright, so we're back on the power supply, and as you see we are working. One thing to note also is when I worked on this last night, the amp draw did come down, I think, around to about 0.3. Again, maybe the capacitors were forming and straightened up. I don't know. I think also part of the reason why things may also be getting warm on the 12 volt section as well as the 120 volt is I'm shoving more voltage into it than it wants. And as you can see, we did come down just a digit. So it's slowly coming down. We are scanning. If we turn the squelch that away, what do we know? Well, we know that when I adjusted the squelch, this stopped like it was supposed to, displaying a frequency. So that's also telling us, if I readjust our squelch, it's telling me that our squelch control is working. So we don't have an issue in our squelch control. However, you note that our volume control is full bore. We have nothing coming out of the speaker. So to address, well, maybe we've got a speaker issue, let's go ahead and plug in a amplified external speaker. And you can hear it coming to life just by touching. And we have no squelch noise. Okay, so, well, maybe it's old and we need to have a signal pumping through it. Okay, let's buy that. No matter what channel the squelch lands on, it's going to be the 121.500. And for those that are taking notes, 121.500 is the emergency frequency for aircraft. Why this radio defaults to that on all of them, I'm not sure, but that's it's working by design. Now, as far as the input frequency, if we look back here on our spectrum analyzer, we can confirm that our signal generator is outputting a 121.5 megahertz signal. We do have our audio generator turned on as well. Since aircraft is AM, we are in the AM mode. So let's go ahead and disconnect from here. And from here, we'll plug in our signal. And this radio is old school. It uses one of those connectors, the Motorola. Okay, so now we have a input going into the radio. Turn our squelch off. Now look at that. We cannot turn our squelch off because it is receiving a signal. To confirm that we're receiving a signal, our signal generator is set to a negative 10 dB. And let's go ahead and just adjust that. So we're 0.1 volt set to 0 dB on the display. So we'll go ahead and turn this down, and you can't see because my arm's in the way. What if we do that? There we go. So now, turn this down, and a meter's not in the camera shot. There. So our meter is right here, and we're still stationary there. Still too strong of a signal. All right, really sensitive, as you can see. I had to turn this way down to 0.01 millivolts, negative 90 dB. So let's go ahead and get my arm back in the way. Let's turn the gain back up on this, and we should see that stop as soon as it gets a signal. And there we go. So what is that telling us? It's telling us that the device is receiving a signal, that it is going through all of its components, doing what it should do. It's working as designed. But we're still not hearing a noise coming out of the speaker. So that's telling us that we have an audio issue. I do not have a schematic for this device. One is not available that I could find. If you're aware of any, let me know, whether it's for free or for a fee. I would greatly appreciate it. However, the twin to this, the K100, which looks like this and came out at the same time as this. The only difference between the two, this one here is aircraft only, where that one is VHF, high-low, UHF, excluding the aircraft band. I did find that manual last night, and I went ahead and ordered it. So as soon as that comes in, I'll have a manual. I'm hoping that manual, that these two radios internally share components, such as the power supply section and the audio amp section. So again, we know that my arm keeps getting in your way, that it works. And it's very sensitive too. I don't want to quote the book because I don't have it right in front of me, but I think it did say it was really sensitive. All right, so what to do next? Let's go ahead and undo the power on this. up inside here, I know you can't see it. I know my light's horrible. But poking around, looking at the chips, there's a lot of chips in here that are proprietary. So hopefully we don't have a bad one, right? Well, I did find we do have a LM, was it 800? I'm sorry, an LM308 audio chip. Way back here. I know you can't see it because I could barely see it, but it's right here. We have the transformer, we have some capacitors, and then just on the back side of those caps is the LM308. The LM308 is a audio amplifier. So my next step is I'm going to take my BDST signal generator, and I'm going to go in here and poke around on the input and the output and see if I could hear any static noise. There's no comfortable way of getting the probe back there. This is the probe here. And even though I could touch the body of the chip, I cannot touch the legs. So I need to take the face off of the device. I got to be careful because I don't want to break these connections free just yet. I need to in order to replace the capacitor that's on here. But I need to access that chip to look at the input-output. Unfortunately, that chip is up under here, and as you see, I cannot get to it. So also, that will also allow me to access the volume control. So I could also test my input-output on the volume control to see if the volume control itself is bad. So let me do that. Let me tear this apart and we'll test that, and I'll get back to you. Okay, I've got the signal generator fired up, or I mean the that thing, signal tracer, and we got the volume control up, squelch down. I've got no antenna connection into it, so all we should hear is static noise. And that resistor is really getting warm. So pin 2, I believe pin 2 is the input. I know you can't see, it's really hard to even for me to get in here, but we can do it. Alright, so that's our input. Turn the squelch off. Oops. And then pin number 8 is our output, and this is a 14-pin dip, which, going through my supplies, I just so happen to have. But let's see here. Really a tight fit. So, what does that tell us? That tells us that our audio amplifier is working. It tells us that our volume control is working. I believe. Should. Let's inject a signal just for the heck of it. And we've got a 1000 hertz tone at about 30% modulation. We'll try for the input. It's hard for me to see because it's really tight and I got wires in the way. There we go. Now let's try for the output. I changed it to a 400 hertz tone, and if I vary the gain on that, you see it does work. I turn up the amplitude input signal. So it's working. Try the input again. Okay, so it works, and this is getting mighty hot. The cardboard on the transformer. Transformer case. The resistor. transistor. The capacitors are all about 92. Except for the one closest to the resistor. So we need to find out what's going on with that. But it works. That's the important part. It works. All right. So I think what I'm going to do next is I'm going to go ahead and disassemble this, remove the front, and come back in and pull the rest of these capacitors out. Looks like there's 1, 2, 3, about 4 more in the power supply section, and then I got 4 more over this way in the AF section. I'm going to go ahead and pull those and swap those out too, and I'll go ahead and check out the rest of the components in this area and see if I have any unseen issues. Alright, so there is something I forgot that I should check, and that's the speaker. I figure since I got it tore apart, let's check the validity of the speaker. And so I have a 1000 hertz 1 volt signal going into the speaker, and I am not hearing anything come out of that. That should be nice and loud. So let me grab a external speaker here just to confirm that my output is good. So you could hear that. So our output signal is good. That speaker apparently is not. And that's a Taiwan ROC speaker. I can't make out the words on it. So okay, so that will explain that issue, why we're not getting any output noise. But that don't explain why we're not getting anything through the external speaker jack, right? Because coming off of the speaker, there is only 2 wires. Let me adjust the output on that to 5 volts peak to peak. And that thing should be, okay, so if I poke the speaker cone itself, I am getting a signal. It's not very loud, but I am getting a signal. So, does that mean I've got a bad speaker wire coming from the connection down into the spider? So let me just wiggle the wire itself. Yes, if I wiggle that wire that comes from the connection down into the cone, then that does make the speaker, but it's not very loud. So I'll, since I got the soldering iron fired up, I'll reseat that and see if that does anything. So just wanted to bring you back on that and let you know that found another issue. In the audio chain.